Hello, my name is George Samet, and this is my presentation on the criteria design pattern. In selecting this pattern, I was looking for something unfamiliar, as well as something that would be applicable to the term project. Upon further research, I found that this pattern is not well documented, and the documentation that exists is relatively old and relatively poor. There are differing interpretations as well as implementations of this pattern. This ultimately led to me defining the pattern, as well as identifying implementations and uses. The intent of this pattern is to obtain a subset of a given data set by applying an evaluation mechanism. In other words, to filter data using some type of criteria. A few key points to remember about this pattern are: you should be able to use multiple criteria in your filtering. The criteria should specify inclusion as well as exclusion rules. We do not modify the original data set, and it's best to keep the data, the filter, and the criteria decoupled. This pattern is also known as a filter, or some adjective followed by filter, for instance, table filter. Consider the following problem. We're validating an airline business case that requires a connecting flight as well as a flight that has a passenger facility charge. The reservation system, however, is not designed to search for such flights. So in this problem, we have a tester that's trying to apply a specific business case using an airline reservation system. That system is going to provide him a list of flight itineraries, and he needs to find flight itineraries that have connecting flights and passenger facility charges. To compound the problem, those itineraries change daily, and we have little testing resources to search for such itineraries. Furthermore, those itineraries are really ancillary to the actual business case being considered. The solution to the problem is to programmatically filter those itinerary responses based on the tester's needs. In other words, to filter data using some type of criteria. This slide depicts our solution. On the right-hand side, colored purple, is our data set, which essentially is composed of trips and flight segments. On the left-hand side, colored blue, is our criteria. The trick here is that we have to be able to identify a connecting flight as well as a passenger facility charge, and we'll show you how to do that later on in this presentation. In the middle is our itinerary filter. The filter takes the data set, applies the criteria, and produces a subset. This pattern is useful when you need to have different views of the same data, or when obtaining data is expensive. In other words, we don't want to continuously retrieve the same data with heavyweight calls just to change the format of its view. This pattern is also applicable when filtering is not easily done at the time the data is retrieved, which is the example we've given here. Finally, this pattern is applicable if the criteria can be reused or combined into a library for later use. The pattern is not applicable if filtering is trivial or easy, or other mechanisms exist to do the same thing. The pattern is also not applicable if there are few criteria to reach a result. In this case, the effort involved in creating the criteria and the filter probably outweighs the benefits. This slide shows the general structure of the pattern. On the right-hand side are our filters. You'll see that we have an abstract filter that has three methods. The first one allows the user to set the criteria. The other two are our filter methods, and we'll talk about filtering out and filtering in later in the presentation. But effectively, this is the method that's going to take our data set and generate the subset. And of course, we have a concrete implementation of that filter. Now you'll notice that that filter maintains a criteria, and that's a single criteria. We'll talk about that a little bit later on in the presentation as well. On the left-hand side of the slide are our criterion, which has a single method that determines whether or not that criterion is satisfied or not. And of course, we have a concrete version of that criterion. Now you might be asking yourself, at the beginning of the presentation, you said that we had to be able to use multiple criteria, but here we only show a single criteria. I'll show you an example how we get to a case where we start chaining the criterion later on in the presentation. This slide depicts our criterion in much greater detail. At the top you'll see our interface, which we've already discussed. It simply has an isSatisfied method. Underneath that, you'll see three concrete criterion. The first one we've already discussed. The one in the middle allows the user to set a series of satisfying conditions. Say for instance, our criterion deals with colors, and our satisfying conditions are the color blue, red, or yellow. Rather than have three separate criterions, in many cases it's useful to have a single criterion that's able to accept all three of those as satisfying conditions. It's useful to note, as depicted on the right, that you're able to type your criterion, as we do with our flight segment here later on in this discussion. Underneath those, you'll see two operations, binary and urinary. The first one allows us to do things like, say, have a criterion with the operation of not. So we want something that doesn't match that criterion. The binary criterion's probably more useful and allows us to do things like this criterion or that criterion. Or you could do something like this criterion and that criterion and that criterion. So this is how we get to the chaining that we discussed earlier. And we'll show an example of that later on in the presentation. This slide depicts our filter in much greater detail. Again, we have an abstract filter that allows the user to set the criteria that will be used to determine the subset. Again, we have a filter in and a filter out method, and I promised I would explain that in more detail, and this seems like a fitting place to do it. Filter in means that as we iterate over the data set, any data that satisfies the criterion, that is, the isSatisfied method returns true, is copied into the subset. Filter out is the exact opposite, meaning that those data that meet the criteria, the isSatisfied method returns true, are not copied into the subset. But again, it's important to note here that we're not modifying the original collection. We're creating a whole new subset. And of course, with an abstract filter, we have to have concrete filters, and you'll see that we have two depicted here. Again, you can have one that operates on generic objects, or you can have one that's strongly typed, and we picked a strongly typed one in our example later in the presentation. But it's very important to note here that in the concrete criteria, you do not see the data set itself. Again, the filter does not maintain the data set. It's important to keep them independent. The first participant in our pattern is the collection, which is not an active participant. It's simply a container of data. Its implementation is irrelevant, and remember, we're not modifying it here. We're returning a subset, a completely different set of that data. It's important to note that the data should have some type of commonality. It doesn't really make sense to iterate and have criterion that operate over just general random objects. The second participant is the filter. The filter accepts some criteria, iterates over the dataset, and checks for performance. We've discussed filtering in and filtering out, but I'll review it here. Filtering in is when the matches are put into the result set. That is, the isSatisfied method returns true. Filtering out is when the matches, isSatisfied method returns true, are not copied into the result set. Of course, we have a concrete filter, which is simply an implementation of the abstract filter. The criterion is the main player in our pattern, which is why I prefer to call the pattern the criteria pattern as opposed to the filter pattern. Its general behavior is to check for conformance. We've shown that there's a concrete criterion, as well as several operations. Here's the logical flow for this pattern. First, a user obtains some data in a format that's not very usable to him. He then identifies some criteria that's capable of reducing that data set. He creates a filter and applies that criteria. He instructs the filter to process that data. The filter generates a hopefully more manageable data set, and our user is happy. The greatest benefit of this pattern is that if implemented correctly, as we've shown here, the data and the criterion are completely decoupled. The criterion needs to know about the data that it's operating on, but the important part is that the data does not need to know anything about the criterion or the filter for that matter. This allows you to amass large libraries of criterion. The drawback is that occasionally those libraries can become large if not managed well. This pattern requires effort. Although it's not terribly difficult, it's not trivial either, so that there is a trade-off between usability and effort. And finally, it should be noted that several people confuse this pattern for one which is applicable to selecting data. This pattern is not for selecting data, it's for filtering it. We've already covered most of these implementation notes, but they're probably worth a review. First, the dataset. The dataset should be completely independent of the filter and the criteria. And recall that it is not modified as part of this pattern. The filters themselves should also be decoupled from the criteria. You do, however, have to allow the user a way to specify that criteria, and the user may, as part of the process, change the criteria that the filter is using. But the filter and the criteria are completely independent too. That is, the filter is a separate entity. This allows for a much more flexible implementation. With respect to the criteria, we've discussed the three variations. The first being a strongly typed criteria that knows exactly the data type of the data it operates on. This yields a very simple implementation, and I'll show you an example of it shortly. The non-typed implementation, where the criterion operates on generic objects, yields a much more flexible implementation, but is generally more complicated as well. We also discussed implementing a criterion that takes satisfying conditions, where we have multiple satisfying conditions as opposed to a single satisfying condition. We discussed chaining using the operations. The chaining allows us to take multiple criteria and convert them into a single criterion. For instance, criterion 1 and criterion 2 together, or criterion 3. And we'll show you an example of that shortly as well. I wasn't able to find any commercial applications of this particular design pattern. The vast majority of examples that I found were either trivial or textbook in nature. With respect to the related patterns, the way in which the participants are separated is very indicative of a model view controller pattern. It's very conceivable that one could use a builder or a factory to generate the criterion, and the nesting of the criterion is very reminiscent of the decorator pattern. These are the references that I encountered during the research for this pattern. Immediately after this slide, a video will start that will take you through a sample implementation of this design pattern. Immediately after the video, the presentation will end. So I'll take this opportunity now to thank you for your time. The first thing I'd like to show you is our code base. And you notice that this code differs slightly from the example in the presentation. And the reason that it differs, it has to do with the data type, and I'll explain that in a moment. This is our filter. As you can see, it's implemented as an interface, a strongly typed interface using Java generics here. It has the ability to set a criterion so that the user can specify a criterion. And then it specifies the ability to be able to filter in and filter out. The availability record filter is our concrete implementation of a filter, and it executes on availability records. Now, availability records are records that the Southwest Airlines Flight Availability Business Service provides in its interface. So what we're going to do in this test is we're going to go out and we're actually going to talk to the Southwest Airlines Business Service that provides flight availability. That service will in turn go and talk to the reservation system to get that availability, apply its business logic, and then return us these availability records, and that's what we're going to filter in the example here. So you'll see that it stores a criterion, and that's achieved through the setCriterion method. And then of course we have the filter in and the filter out. Now the filter in simply iterates over the passed in collection, looking for any criterion that is satisfied. So if the input data in that particular collection on that iteration meets the satisfied method, we add it to our result set. The filter out operation is exactly the opposite. So if the criterion is satisfied, if the criterion is satisfied, returns true, and then we negate that. So if it's not satisfied, then we add it to the result set. Our criterion object, our criterion interface, has the simple is satisfied method. Before we get into the concrete criterion, we'll take a look at the operations that we talked about earlier. So this is the binary operation. It has a left-hand side and a right-hand side operand. The only constructor forces the user to provide those. Concrete implementation of that class is AND in this example. So AND extends the binary criterion, but it's also a criterion in itself. Again, the constructor forces the user to specify a left-hand side and right-hand side. And then here, we implement the is satisfied, which is simply the is satisfied method of the left-hand operand ANDed together with the is satisfied with the right-hand operand. So you can see how OR would follow with the or any other variation you'd like to create. With the not operation, I simply implemented the criterion. I didn't go through a unary operation here because it really adds little. It just basically would store the criterion for you here that we do. So this follows almost exactly the AND pattern, except for instead of ANDing two operands together, we simply negate the is satisfied method. We have two concrete criterion. The first one is called nonstop, and that one's going to ensure that the flight that we're looking at is a nonstop flight. So in our availability record, they made it very nice for us. They gave us a number of stops method at the top level of that particular record. So all we need to do is ensure that the number of stops is 0. That would indicate a nonstop flight. We're also going to filter on equipment type. Now Southwest Airlines operates 737 aircraft and several different variations of that. Like this, for instance, the 737-700, 737-500, and here are the codes here on the left, and you'll see those in the example. So in this particular one, we implement it as a set of satisfying conditions. So here we have a set of the allowed values. So anything in this set would satisfy the is satisfied method. So this again is an opportunity here if we have several different types. Instead of implementing a criterion for 73W and a criterion for 735, we can implement it this way. So the is satisfied method simply checks to see if the input equipment type is contained in our allowed set. So now we're going to run some actual tests. I'm going to run the test first and then I'm going to explain to you how it works because the tests do take a little while to run. So here we're running a test called get availability with equipment filter. Let's go ahead and run that, and we'll talk about the test and come back and see the results. So this particular test is going to ask the reservation system, actually ask the business services, which will in turn ask the reservation system, for flights between Dallas and Orlando over the next 2 days. It's going to take that result set from us. It's going to actually print it out, so you'll see what the full result set is. And then we're going to create an availability record filter, and we're going to add a new criterion here. It's called equipment type. So the equipment type criterion, and we're going to only look for 735 aircraft types. So that's what's going to satisfy this particular criterion. First example, we're going to filter those in. So we should get back only those that have 735 in them. And then the second part, we're going to filter those out. So those will give us everything other than 735 aircraft types. So let's see if that's succeeded. And it has. We have one test run, 0 errors. Let's take a look at the result. Okay, so here's our availability record, and for some reason the reservation system right now, this is our test reservation system of course, is only returning nonstop flights. So you'll see that all of the stops here are 0. Here's our equipment type, that's the flight number, and then that's the day. So when we filter it in, we receive 4 results. All of those are 735 aircraft type. And if we come back up here and look, we should have 4 735 aircraft type flights. There's 1, 2, 3, and then the 4th. 1985 and 1197 are the flight numbers. And we see both of those on both days. Now when we exclude the 735, when we filter it out, we should have the rest of the data set. And that's the rest of the data set. So that's the first test, a relatively simple test. In the second test, I'm going to show you how to combine some criteria. We talked about chaining those a little bit earlier. In this next example, we're going to expand on the test we ran earlier. So I'm going to run this guy. This one's a little different. It's with equipment type and nonstop filter. And again, this is going to take a while. So as that's running, I'm going to explain the code. So here's our same itinerary, Dallas to Orlando. Next 2 days. However, here we have 2 criterion. We have a nonstop criterion, so only the ones with the 0 stops, and then the 735 aircraft type that we saw a few minutes ago. Here's our filter. So in our filter, I create a new AND criterion, and I give it nonstop and 735 aircraft type. So what we're going to do is we're going to include nonstop flights that are on 735 equipment types. And then here I'm filtering in those records. Now this is an example why you want to decouple your filter from your criterion, because I'm going to come back immediately after that and I'm going to set a new criterion on our filter. So I'm going to reuse that same filter. So I'm going to reuse that same code that knows how to iterate over that particular data set with a different criterion. So in this case, I'm going to negate the non-stop, so I'm going to look for flights that have stops, which of course we have none as we saw. Still using 735 aircraft types, and I'm ANDing that. And this is a good example of how these could get potentially complicated. So I think a builder pattern or some type of utility to create those would probably be a good idea, because they can get kind of complicated as you get to larger sets. So let's take a look and see if our test has succeeded, and it has. So 1 test run with 0 errors and 0 failures. We'll take a look at the result set and see if we get what we expect. Okay, so now we'll see the exact same itineraries we saw in the first test. So there's our list. And then when I include 735 and non-stops, this is the exact same results that we had before, since everything is a non-stop flight. However, when I look for other than non-stops and 735 aircraft type, I get back an empty set, because there are no flights that don't stop. There are no non-stop flights, so all the flights are non-stop flights. So this effectively tests the different permutations of the criteria design pattern that I explained in the presentation, and concludes the example.